Hey there, welcome to the lab. Today we're going to have a look at this Uni-T. This is a 161E. You can see that, UT161E. So this is the sort of top end of the 161 line. So it's a 22,000 count multimeter, and we'll have a look at the operation of this unit. Now, before I get started, if you found this video to be helpful, please give it a thumbs up and subscribe to the channel. Questions and comments are always welcome. The feedback is appreciated and it helps me figure out where to focus my activity. And in case I forgot to mention it, this is a unit that I bought with my own funds in order to be able to do an evaluation. Now, without further ado, let's get into the box. So, opening it up, there's a pouch here. Nothing else in the box besides the pouch. Pouch is nicely labeled Uni-T. Unzip it, and there's a whole bunch of stuff in here. There's a document download guide. Okay, so this basically tells you how to get to the Uni-T website and download some docs. And there's a user manual here, and the whole manual here is in English. So, and it's about 36 pages, so there's a lot of information here in this user manual. You can kind of see it shows how to perform almost every kind of measurement test, so a lot of information there. In the package here we've got a little block. I think this block is something that we would plug in to the meter in order to test. It looks like some transistor tests and things of that nature. So test block for transistors, put that there. Some straps here. There's a lot of stuff in here. There's a USB interface. So I guess we'll have to figure out how that works. So this is designed to allow us to connect the meter up to a PC, I guess. And then we've got some probes here. Let's unbundle the probes. Pretty long probes. It's hard to tell, but fairly long probes. And but they feel like PVC, so not silicone. Now they are branded for Uni-T here, and they've got some sheath on them. That comes off not too bad, nice and pointy, and they appear to be gold plated, so that's nice. So not too shabby, decent set of probes, and sort of a fancier case than most. It's got a divider here to separate between the probe storage and where the multimeter is. Multimeter here. It's a fairly large unit. And it's got a little bit of heft to it. You can see where the USB is supposed to plug in there, and some batteries. Nice thing, it has a ETL certification, so that's nice to see. And it says it takes 4 AAA batteries, so we'll get those in a second. And the rubber, the overmolding here, feels nice and solid. Now, just to give it a little bit of a size comparison with a few other meters, we've got a Fluke 117, so it's a little bigger than the Fluke. The Fluke turns out to be a fairly compact unit. Another meter we'll compare it against is the Brymen 789, and the 789 is a fairly large unit, and so it's pretty close to the same size, maybe a touch smaller than the 789. 789, a little narrower in the hand grip, but otherwise they seem pretty comparable in size. All right, so let's get the batteries into the unit here, and then we'll power it up. So I've taken the back cover off. A couple of things to point out. Of course, on a meter of this quality level, there is a threaded ring. Hopefully you can see that in there for the screw. But the other thing that's very nice is that it's easy to access the fuses for the unit. So we've got the fuse here. This is for the 10 amp fused range. Well, actually it says 20 amp max. So they've probably done something to that. The fuse itself says it's 11 amps, so they're probably doing something to split the current somewhere in there. And the other fuse here for the lower range says it's 600 milliamp. So it's nice that the fuses are easily accessible. In a lot of units of this sort, you've got to kind of take off the overmold and take out all the screws and kind of almost tear the unit down in order to get to the fuses. So it's nice that the fuses here are exposed and easily accessible once you take off the back door. That's a handy thing. Of course, you don't want to blow the fuses, but if you do have to replace them, it's nice to see that it's not a major chore. Now let's get the batteries in. And we'll put the door back on. Okay, now it's ready to be turned on for the first time. I don't know, we'll just randomly turn it on. Okay, so that's in AC volts. There's an AC plus DC mode, millivolts, AC, and potentially DC, although, yeah, that's DC millivolts. So, pretty nice. And I think there's a light here. Let's hold this. Okay, so the backlights come on. Maybe you can see that. And that's with the backlight off. So fairly nice backlight. Not super bright here in the studio, but or in the lab, but it would be bright enough if you were in a darkened environment. Very, very nice. And I have to say that the whole meter it has a really nice feel to it. It really feels like a step up, if you know what I mean. So now let's put it through a few paces. And what I'll be doing is I'll be doing a few little comparisons against the Brymen 789 in situations where it's not too problematic to do the comparison. So we're first going to look at DC voltage. So I've got the Uni-T in DC volts. I've got the Brymen in DC volts as well. The Brymen has kind of a combined AC-DC mode, but I've put it into the DC mode directly so it doesn't have to figure out whether it's AC or DC. And I've got a reference source here for voltage, and I'll call out the units as I go through them. It's not on yet. You can see the Brymen is pretty steady at 0. The Uni-T kind of a little bit of noise there, showing up as a 10,000th of a volt, I guess. So now I'm going to turn the power on to the reference source. Okay, and so that's 10 volts, and the overlay shows the calibrated values. So the Uni-T seems to be really close. Now we'll go, that's 7.5 volts. Brymen seems to have a little bit of a better read there. That's 5 volts. And once again, the Brymen is a little better there. And that's 2.5 volts. Once again, the Brymen just a touch closer to the calibrated reference voltages that you see on the overlay. But then again, the Brymen is a 60,000 count meter, and the Uni-T is only a 22,000 count meter. So really a very excellent showing for the Uni-T, all things considered. Now for AC volts, I've got both units in AC voltage mode, and I haven't turned the power on yet. You can see they're both showing a little bit of ghost voltage, and they're pretty much synced up with each other. It's hard to see any difference at all between them. Let's see what happens when I turn the power on. So looks pretty good. It's very hard to see much of a difference. There is sort of a few hundredths of a volt difference between the two. Very good showing for the Uni-T. Let's turn the power off and on again. So performance is really, really good. And on the Uni-T, in order to show the frequency, we can press this button, and that shows 60 hertz. On the Brymen, 60.021. So a little bit more accuracy on the Brymen. Once again, kind of expected, but once again, also another very excellent showing from the Uni-T. Now we're going to have a look at resistance, and there's a set of calibrated resistors here. The actual calibrated values will be up in the overlay. I'll call these out as I go through them. I'm using the probes that came with the Uni-T. So let's start here. This is 10 ohms. This is 100 ohms. This is 1,000 ohms, 1K. This is 10K ohms. And 100K ohms. So very good performance from the Uni-T. Extremely, extremely close to the calibrated reference resistances. Now we'll run through the Brymen for resistance, and I'll be calling them out. This is 10 ohms, 100 ohms, 1K, 10K, 100K. So you can see just a little more precision in the Brymen. Now we're going to look at capacitance. Once again, some calibrated reference capacitances. The actual calibrated values will be in the overlay. So this is 100 picofarads. A little high there. This is 1 nanofarad. It's again a little high. 10 nanofarads. A little low maybe. 100 nanofarads. Okay. This is 1,000 nanofarads. And 10 microfarads. So a fairly decent showing there from the Uni-T. Now we'll be looking at capacitance with the Brymen. And let's just start here, 100 picofarads. So a little high. This is 1 nanofarad. 10 nanofarads. 100 nanofarads. 1,000 nanofarads. And 10 microfarads. So about balanced with the Uni-T there. So I think the Uni-T has done a pretty good showing on the capacitance measures and the resistance measures. Now diode check with the Uni-T. So I've got a little test box here. Let's see, this is mainly to show how the unit behaves. So this probe there, and I like that. I like the beep and the light as well. So that's showing that there's a valid forward bias voltage. Then it also beeps here for the LEDs. That's different. Okay, so it seems to have to, the bias voltage has to be below 2 volts. So it lights up all the LEDs, and this is the short. That shows the short. So the Uni-T will give us a little short beep on anything that has a forward bias voltage, it seems, under 2 volts. So that's very nice. That's very nice. That's one of the features that I really like to see in a multimeter, is that little short beep on the diode check. So diode check on the Brymen. So the short beeps off of these two as expected. No beeps for any of the LEDs, and the long beep for the short circuit. Now for continuity, I generally am looking at how quickly these respond when I tap the probes together. So I'm in continuity mode, and these probes are gold plated, so they should be very good. Okay, so that's very good performance from the Uni-T. And of course, if the contact stays long enough, the light at the top goes off as well. But the key thing is the beep. I'm really interested in how responsive the Uni-T is to the beep. Continuity on the Brymen. I'm using the probes from the Uni-T, but very fast response from the Brymen, which includes, as you can see, aside from the beep, it includes flashing the display, but I'm usually not looking at the display when I'm doing continuity tests. I'm usually just looking for the beep sound. So excellent performance out of both units. Now for DC current, I've got a little circuit on a breadboard here. Very simple circuit. It's going to feed 5 volts through a 150 ohm resistor. The meter has to be inserted in series with the circuit in order to measure the current. If we use Ohm's law to calculate out what the expected current is for 5 volts and 150 ohms, we get about 0.033 amps, so about 33 milliamps. So for current here for the Brymen, this is in the milliamp range. We see 32.2725. We'll turn that off. We'll go to the amp range now. Turn that on. 31. 31.2 or 0.0312, depending on how you want to look at it. 32, there we go. So this is the more typical value that I expect out of this circuit for coming close to, this is almost the ideal value of 33 milliamps. This is the Uni-T in the milliamp range. So a little low compared to what we would expect. So it's showing about 30 milliamps. We'd expect to see something a little higher than that, closer to 33 or 32 would be a typical read that I get. And let's just move this over to the amp range. And so the amp range, you can see that's oscillating between 29 and 30 milliamps. So the Uni-T is measuring about, let's say 1 or 2 milliamps lower than I would have expected given the circuit and past behavior that I've seen on this circuit with other meters, and certainly lower than what the Brymen was showing, which was coming close to the ideal 33 milliamps. Now for non-contact voltage, I have this power cord here, and the hot wire is along this edge here of the receptacle cord. And on the Brymen, the non-contact voltage sensor is over here on the side. So something is kind of flowing through me, I guess. And on the Uni-T, the non-contact voltage is labeled and it's up here on this side. So let's see what happens as I bring this power cord towards the sensors. So we'll start with the Uni-T. So it is picking up the sensor, or the presence of the electrical field. Now it's not showing the field being very strong, and kind of need to be almost on top of the sensor to get a very strong reading there. Now the Brymen has an adjustable sensitivity level, so you can see that Brymen is just more sensitive overall to the non-contact voltage. So I can't get anywhere near that level of a response from the Uni-T. The Uni-T 161E also has the capability to measure transistor gain. That's with this position here. It's labeled HFE. That's sort of the electrical notation for gain. It's also given by the symbol beta, as you'll see when we turn it on. So we have to plug this block in. And I have a transistor here. This is an NPN. It's a bipolar junction transistor, BJT. It's a 2N2904. And let's just first turn this on into the right mode so you can see the little beta here. And we've got to plug this in into the right pins. Emitter base collector. And it's a little finicky with the contacts. The range for these models of transistor, I don't know exactly who the manufacturer is, but in general, if you were to look up a 2N2904, the gain is somewhere between 100 and 300. So this one is showing 292. It's a little bit tricky to tell whether that's a valid measurement or not. So one of the things that I can do is I've got one of these multi-testers. And so if we take the same device and we plug it in here, now of course this is not the most accurate device in the world, but we can turn that on and it says it's a BJT and it says the gain is 322. So, 290, 322, they're kind of in the same ballpark given the sort of variance on these devices. So I guess it's reasonably close. The most problematic part is just getting it into the pins here and making sure you have good contact. So that time I've got good contact, but if I poke it a little bit, you can see that the contact kind of varies. It goes to 0. So it's a little tricky. I guess you can tell when there's no contact because it shows 0. But not the easiest way to measure the gain on transistors, but it does work, and it does seem to return a reasonable result. What you see here is the interface for the PC app that can be used as the data logger for the Uni-T 161E. Now I haven't connected yet, so just really quickly, these little window panels can be moved around, but it usually doesn't do any, it's usually not the greatest thing to move them around because the display works best when they're in their default location, and you can see it can be a little tricky to get them back into the desired spot. after moving them. So the behavior is very finicky with this application there. Now, what I can do is I can connect here. And when I click on the connect button, I get this little pop-up window. And for some reason, I have to choose the second one here as the device. And as long as the meter is on, it'll connect. And now it starts reading out values. In order to show this piece, I'm just using DC volts, and I'm going to turn on a voltage reference source in a second. So by default, it's set up with some options here to sample every second. So you can change the sampling rate down to, I guess, 1 millisecond, which would kind of generate a huge amount of data. We don't want to do that. I'll drop it down just for a second to 250 milliseconds. And so you can see that it's now cranking out a lot of samples. I'm going to change it back. I'm going to now set it to every 2 seconds. That should be good enough for what we want to see. So 2000. Now I can clear the data if I want, either with this trash can or this trash can. So yes, we'll delete the data. And of course we could also save the data and print the data here if we want to. Without any input, the values are kind of jumping around a little bit. So now let's just turn on the reference source. So that's reading, as you see, 9.987. Supposedly that's 10 volts out of the reference source. I'm just going to clear that again. So 998. And the sampling rate on the Uni-T might be a little bit quicker than what's coming out on the data logging. So the data logging sampling rate isn't intrinsically tied to the sampling rate on the multimeter itself. Now we can change, of course I'm going to change this, that's now down to 2.5 volts. And I'm going to now change, that's the 5 volt setting. That's the 7.5 volt setting. And now back to 10 volts. And so you can see that is charted out for us fairly nicely, and I'll drop it down to 2.5 volts again. And the sample values are shown here pretty much the way we would expect to see them, more or less. The controls here in this little toolbar mimic the controls that are available to us on the multimeter itself, although you could kind of say, well, you know, that turns on the backlight on the multimeter, that turns off the backlight in the multimeter. So all of the control buttons that are available on the multimeter are mirrored here on the toolbar. If data logging is something that is important to you, the USB connectivity along with this app can be very helpful. This app is Windows only, but it does turn out, if you're into open source and Python, there is some code available on GitHub in Python that should be able to pull the data across the USB interface in a similar fashion to what this PC-based app is doing. In summary, the Uni-T UT161E has shown itself to be a pretty decent multimeter. The measurements around voltage, resistance, capacitance, diode check, all of those were really good. The one place where the Uni-T seemed to be a little off compared to the Brymen was the DC current. The DC current seemed to read a little lower than I would have expected, sort of different enough that it's worth noting. And the other place where the Uni-T or the Brymen really does have a bit of a leg up was on the non-contact voltage. the non-contact voltage on the Uni-T was kind of typical for most multimeters in the sense that they don't really excel at non-contact voltage. The Brymen and the Fluke, for that matter, that you might see in some of my other videos, they do very well for non-contact voltage, but in general, most multimeters don't do a fantastic job at non-contact voltage. You know, it's a little bit different with the Uni-T having this block for measuring transistors. Whether that's your thing or not, you know, that's kind of up to you. Um, it's a little odd that they've traded that off for temperature, which is available on some of the other models, but those other models are lower counts. They're sort of 6,000 count multimeters in the 161 series. So to get 22,000 counts, you have to also take this transistor unit and you have to give up temperature. The one thing that was pretty cool about the Uni-T was the data logging that could be done by connecting it to a PC. There are a couple of models in the Uni-T lineup. In fact, even the Uni-T 61E has data logging capability through the USB, but the 61E doesn't actually come with the USB cable, whereas the 161E comes with the USB cable in the package. So that makes it a little a little more likely that it will get used if it's available. Final call here. It's a fantastic meter. Not quite as fantastic as the Brymen. The Brymen still rules the roost in that area. A really fantastic meter and 60,000 counts. So a really fantastic unit in the Brymen. But one thing I just don't want to forget is that the diode check on the 161E works in exactly the way I would hope the diode check mode works, in that it gives us that short little beep, which is something that it turns out a lot of the more budget multimeters don't do. A lot of the more budget multimeters don't have that beep in diode check mode when measuring valid forward biases. So that's a nice feature to see and very much appreciated in the Uni-T 161E. Okay, well, if you found this video to be helpful, please give it a thumbs up. Please subscribe to the channel. And until next time,